Okay. So good morning, students. Welcome to the real analysis live lectures. In previous lecture, we have seen Archimedean property and its two equivalent statements. What is Archimedean property? Let x and y be two real numbers with x greater than 0, then there exists a natural number n such that nx is strictly greater than y. Or other form of Archimedean property or equivalent statement, we can say that n is not set of natural numbers is not bounded above, right?
Yes, ma'am.
We have proved also, okay, and we have proved these two statements are equivalent to each other. Both versions of Archimedean property are equivalent, okay. Now today we will see density of rational numbers. Density of rational numbers. What is mean by dense set? Dense set you might have familiar in your BSc. Can anybody tell me? Set of rational, I want to prove set of rational numbers is dense in R. R means real numbers. Means you take any two real numbers, there exists at least one rational numbers in between that. Right? Can you hear me?
Yes, ma'am.
Yes, ma'am. Yes.
Yes, ma'am.
So we will write as a statement if A and B be two real numbers with A less than B, then there exists R belongs to Q such that A is strictly less than R strictly less than B. What is this statement? A and B are any two real numbers with A less than B. Then we want to prove there exists at least one rational number. This Q. Q is set of rational numbers such that A is less than R less than B. Is this statement is clear?
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
So now, just now we have proved Archimedean property. So using Archimedean property, we can easily prove this or denseness of rational numbers. Okay. So to use Archimedean property, what we require? Two real numbers with one strictly greater than 0 we require, right? In Archimedean property, what we require? Let x and y be two real numbers with x greater than 0. Then there exists a natural number such that nx is strictly greater than y, right?
Strictly greater than y.
So if I want to use Archimedean property, I require two real numbers and one should be greater than 0. So and what is in this theorem given? Let A comma B belongs to R with A is less than B. This is given. So can you give me a real number, two real numbers with one greater than 0 from these two? I am having A and B, two real numbers with one is strictly less than B. Then can you give me a real number which is strictly greater than 0? using this A and B. Using
B
this.
is greater than 0.
What? Yes. Please repeat.
Out of these two numbers, no?
Yeah, using this A and B, two real numbers, can you give me a real number which is strictly greater than 0? B, what can I say about B minus A?
Right, B minus.
B minus A is strictly greater than 0 because A is strictly less than B. Yes?
Yes, ma'am.
So let A and B, two real numbers with A less than B, and B minus A is strictly greater than 0. So now I am having B minus A strictly greater than 0. And if I take another, A and B are real numbers, so B minus A is also a real number I can consider. So I am having x greater than 0. This x I will say in my Archimedean property. And I want to choose another rational number, say y is equal to 1. Y is equal to 1. X and y are two real numbers with x strictly greater than 0. Then what can I say? By Archimedean property, if I want to use Archimedean property, what can I say? There exists natural number n such that what? Nx, n times b minus a is strictly greater than y. Y is my 1. Can I write? Because x and y are any two real numbers, so I can use that y as 1 here. So by Archimedean property, I can say that there exists a natural number n such that n times b minus a is strictly greater than 1. Yes?
Yes, ma'am.
Yes. Now,
Yes, ma'am.
yeah, so what we will get here? This implies nb minus na is strictly greater than 1. Now, I want to prove there exists a rational number. What is our aim? We want to prove a is strictly less than r less than b. And what is r? R is a rational number we want to prove. So r should be in the form of p by q, where q is not equal to 0. P and q belongs to set of integers, right? Rational number. This is my claim, na? I want to prove there exists rational number r belongs to q such that a strictly less than r strictly less than b. Is that okay? And I am having nb minus na. I am having natural number such that n times b minus a is strictly greater than 1, and so that I got nb minus na is strictly greater than 1. So if nb minus na is strictly greater than 1, can I say there exists a real number, integer in between them? nb and na are any two real numbers whose difference is strictly greater than 1. Right? Say like this. nb, na, first na will be there. Na and nb. This difference is strictly greater than 1. So there must exist some integer in between these two.
Yes.
How can I prove this? If I prove there exists integer m belongs to I, or we say z, instead of I we will write z. M belongs to z. Because we are having their difference is strictly greater than 1. So what can I say? There exists m belongs to z such that integer such that na is strictly less than m strictly less than nb. If I if I prove this, then it will be over. My proof will be over. Is it? And this is nothing but what? A rational number. What is this? M by n. N is a natural number. M belongs to Z. So m by n is, I can consider as a rational number.
Yes, ma'am. Yes, ma'am.
Yes. So which implies A is strictly less than R less than B, where R is equal to M by N and which belongs to U. Okay, but for that we want to prove there exists M belongs to Z such that NA less than M less than NB. So how can I say this? You take any two real numbers NA and NB which is strictly greater than 1, whose say 2.5 and 3.6 say this, there 3.6 minus 2.5 is 1.1. It is strictly greater than 1.
Yes, ma'am.
So what is the integer in between these two real numbers? 3. 3 is the real
Yes,
number. Not real number. It is belongs to Z integer. There exists at least one integer in between these two real numbers.
Yes, ma'am.
Any you take say any real 1.1 and 5 if you take. So there are many, but at least one we want. So I am taking if their distance between them is strictly greater than 2, then there will exist two integers. If it is distance is strictly greater than, means if it is strictly greater than 3, then it will there exist at least three integers in between them. Okay, so here we are having only NB minus NA strictly greater than 1. So instead of this I will write here say 2.2. So what is integer I am getting here in between these two real numbers? 2, right? So 2 belongs to Z. This 2 belongs to Z. This is not epsilon, huh? This is belongs to Z I am writing. Instead of here I will write this belongs to Z. Is it? So what can I say here? What should M I choose? What is the guarantee that there exists this M belongs to Z? It is integer part of NA plus 1. What is this 3? 3 is nothing but 2 plus 1. Whatever smaller integer part of this. What is integer part of this? 2. Integer part of 2.5 is nothing but 2. And 2 plus, if I want to write like this. Or what is integer part of 1.1? Integer part 1. So if I add 1 to this, I will get 2, right? So whatever my NA is here, if I take integer part of it, yes, and you add 1 to that will serve my purpose. That will be my M. That will be my M. Are you getting?
Yes, ma'am.
Yes. So
Sorry, ma'am.
yes.
I'm not getting you.
Yeah, up to here it is clear. NB minus NA is strictly greater than 1.
Yes, ma'am.
NB minus NA is strictly greater than 1. Now, since distance between two real numbers is strictly greater than 1, can I say there exists an integer in between them?
Yes, ma'am.
Yes, that only means by intuitive notion it is clear only, because if distance is strictly greater than 1, there must exist one integer in between them. But that we want to prove mathematically, or we have to give what should be that. So if you take so that let m is equal to, here I will write, let m is equal to integer part of na plus 1. If I take m is equal to integer part of na plus 1, it must be, na must be less than m,
Yes, ma'am.
and it must be strictly less than nb also. It must be strictly less than nb also. Just we are
Yes,
adding
ma'am.
1 to it. Okay. And since distance is greater than 1, so I am getting na must be less than m, strictly less than nb. So I can say this m will serve my purpose. There exists m belongs to z. This is nothing but integer. Integer part of na. Na is my real number, and if you take integer part of it and if you add 1 to it, it will become an integer. Right? Are you
Yes,
getting?
ma'am.
Yes. So this implies a is strictly since I am getting na is strictly less than m strictly less than nb, I can say a is strictly less than m by n less than b, and that m by n I can take my r, that is my rational number, right? I want to prove that only. I want to prove existence of a rational number between any two real numbers. Okay.
Okay.
Yes. So this implies where r is equal to m by n belongs to q. So this proves that between any two real numbers there exists a rational number. This is nothing but dense property of rational numbers. Rational numbers are dense. डेन्सचा मीनिंग माहिती आहे का तुम्हाला?
नाही.
डेन्स आपण तुम्ही बऱ्याचदा वापरत असाल ना तुमच्या डे टू डे लाईफ मध्ये. डेन्स हा एरिया किती गजबजलेला आहे, डेन्स आहे, हा एरिया खूप डेन्स आहे, आपण काय म्हणतो? किंवा एखादं फॉरेस्ट असेल त्याच्यामध्ये खूप झाडं असतील, म्हणजे दॅट एरिया इज डेन्स इन ट्रीज. म्हणजे खूप कमी जागा असेल, त्या दोन झाडांमध्ये खूप कमी डिस्टन्स असेल. डेन्स म्हणतो ना आपण, खूप गजबजलेलं आहे. गजबजलेलं म्हणजेच काय की तुम्ही कोणतेही दोन आता आपल्याला इथे काय म्हणायचंय, व्हॉट वी वॉन्ट टू से हिअर, सेट ऑफ रॅशनल्स आर डेन्स इन रियल नंबर्स. सो you know this real number system. These are my any two real numbers we are taking with strictly less than b. So when I will say it is set of rationals is dense, if everywhere I will found that one element of q, right, then I will say it is dense. Whatever we have proved, that is nothing but denseness property of q. Is that okay?
Yes, ma'am.
जर एखाद्या कॉलनीमध्ये खूप दूर दूर घरं असतील, समजा दुबई वगैरे बघितले, तिथे घरं खूप डिस्टन्सवर असतात, म्हणजे खूप एरिया तिथे सोडलेला असतो. पण आपल्या इंडियामध्ये एखादी चाळ बघा किंवा मुंबईमध्ये बघा तुम्ही, झोपडपट्टी वगैरे, थोडी पण जागा नसते दोन घरांमध्ये, राईट? तर तो डेन्स एरिया म्हणतो आपण. ते झोपडपट्टीचा एरिया किंवा जो काही आहे तो एकदम डेन्स एरिया असतो, गर्दीचं ठिकाण म्हणा. आय होप you understood this?
Hello ma'am. Ma'am, आपण जर एखादा
So now what about set of irrational numbers? It is also dense in R. Take exercise. This is for AB belongs to R. Take any two real numbers. AB belongs to R with A strictly less than B. Then there exists S small s belongs to Q complement, or you can say R minus Q, such that A strictly less than S strictly less than B. That is, set of irrationals is dense in R. That only we want to prove. Just now we have proved set of rationals is dense in R. Now we want to prove set of irrationals also dense in R. You take any two real numbers, there exists at least one irrational number. So how can I prove this? I will just give a hint. This you take as an exercise. I will just give an hint. Take A and B. A is equal to A by root 2 and B is equal to B by root 2. So if A and B are these two real numbers, so by previous theorem, these are now A and B are two real numbers. Between any two real numbers, there exists a rational number. So there, by above theorem, there exists R belongs to Q such that A is strictly less, A by root 2 is strictly less than R strictly less than B by root 2, and this implies A is strictly less than R times root 2 strictly less than B. So what is R times the root 2? It is a irrational number. This belongs to
Yes, ma'am.
R by Q. Is that okay?
Yes, ma'am.
Okay. So now we will start next section. I will start with a new page. Sequences. Sequence of real numbers, or sequences, or sequence of real numbers. Numbers. Okay. Do you know sequence? Sequence. We will define it first. Let X be a non-empty set. A sequence in X. A sequence in X is a function. Is a function f from n to x and is denoted by xn or in curly braces xn, where xn is nothing but f of n. You take okay, instead of real numbers we are taking now X is any set, but actually we have to consider here set of sequence of real numbers only. Okay, So I am taking any non-empty set and I want to define a sequence on that set. A sequence in X is nothing but a function from n to X. If I want to say sequence of real numbers, then it will be a function from n to R. Right? What is meant by sequence of real numbers? It is a function from f from n to R. Means its images will be a real numbers. Can you give me for example, 1 by n? This is a sequence. Xn is equal to 1 by n. So if you vary n, you will get another image here, right?
Yes, ma'am.
N is equal to say 1. Then what is my xn? It is 1 by 1, means 1. N is equal to 2, then 1 by 2. N is equal to 3, then it is 1 by 3. And so on. 1 by 4. 1 by 5. And so on. It is a function from n to R. Right? 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. This is a sequence of real numbers. Any another example you can take as n also. Xn is equal to n. 1, 2, 3, 4, 5. This is also a sequence. Right? This is also a sequence. Is that okay?
Yes.
Yes, ma'am.
Another sequence, can you give? One, 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 one. Any constant sequence you can take? What is x1 here?
Minus.
x1 1
Minus.
or xn is equal to minus 1 raised to n. Is it okay? This xn is nothing but what? Okay, instead of writing like this, I will write xn in terms of xn. What is this xn? Xn is nothing but n itself, or which is nothing but this. Xn is equal to here 1 by n, and which is nothing but this. What is here xn? It is just 1 constant sequence, right? And x is equal to minus 1 raised to n. What is this sequence? 1 minus 1, 1 minus 1, sorry, minus 1, 1. N is equal to 1, it will be minus 1. So minus 1, 1, minus 1, 1, minus 1, 1, and so on. This is also a sequence. Is that okay?
Yes, ma'am.
Yes.
Now we define what is mean by a increasing sequence. A sequence definition. A sequence xn is said to be increasing if, when can I say it is an increasing sequence? If xn is less than or equal to xn plus 1 for all n. Xn is less than or equal to xn plus 1 for all n. Then we say it is an increasing sequence, and is said to be decreasing said to be increasing, this one. Secondly, decreasing. When I can say it is decreasing sequence, if xn is greater than equal to xn plus 1 for all n. For example, xn is equal to n. Instead of like this, I will write xn is equal to n is an increasing or decreasing sequence?
Decreasing.
Is an
Decreasing.
increasing sequence. What about xn is equal to 1 by n? Is
Decreasing.
decreasing
Yes.
decreasing sequence. So another definition. So increasing, if definition, a sequence is said to be monotone, is said to be monotone if it is either increasing or decreasing. If it is either increasing or decreasing sequence, we call it that sequence as a monotone sequence. Is that okay?
Yes, ma'am.
Otherwise, it's said to be constant sequence. Monotone sequence. Now, bounded definition. A sequence xn is said to be bounded. When I say bounded, if there exists m belongs to R such that mod of xn is less than equal to m for all n. There exists a positive real number, you say, or just a real number such that mod of xn is less than equal to m for every n. Means every element of that sequence is less than equal to some real number, then we say that it is a bounded sequence. So can you give me an example of a bounded sequence? For example,
1 by
xn is equal to 1 by n is bounded sequence. Whereas, which is not bounded? Whereas, xn is equal to n. What about n? Whether this is bounded sequence? 1, 2, 3, 4, 5, 6, 7, 8. Whether it is bounded sequence?
No, ma'am.
Is not a
No.
is not bounded sequence. Is not bounded. What about xn is equal to minus 1 raised to n? What about
Oscillate.
oscillating? But whether it is bounded, I am not asking increasing, decreasing, or something.
Yes. Yes, ma'am.
Yes,
Minus 1 to 1.
It is bounded sequence. What is that m?
What?
Bounded sequence. Yeah, you can take m1 also or any real number which is greater than 1, right? Because its elements are minus 1, 1, minus 1, 1. So m you can take as 1 or any strictly greater than 1, any real number. Is that okay?
Okay, ma'am.
Yes, ma'am.
Yes. So we have defined increasing sequence, decreasing sequence, monotone sequence, and what is meant by a bounded sequence. Now we define a convergent sequence. Yeah, if it is not bounded, we say it as unbounded sequence. Otherwise, it's said to be unbounded. We will write here. Otherwise, is said to be unbounded sequence. Not bounded or unbounded is same. Okay, next definition. It's important definition again. Convergent sequence. A sequence xn in R is said to be convergent we will say convergent sequence, or is said to, or a sequence xn in R is said to be convergent to x belongs to R if for given epsilon greater than 0 there exists natural number n0 such that mod of xn minus x is strictly less than epsilon for all n greater than equal to n0. So please see carefully this definition. A sequence of real numbers is xn is said to be convergent sequence or converges to x if for given epsilon greater than 0 there exists n0 belongs to n such that mod of xn minus x is less than epsilon for all n greater than equal to n0. What is mean by mod of xn minus x? Since it is a sequence of real numbers, we have taken here mod. Okay, mod is for distance between that xn and x. Okay, xn minus x is nothing but distance between xn, these two real numbers xn and x. So if it is less than epsilon for all n greater than equal to n0, then we will say it is a convergent sequence and it converges to x. For example, 1 by n xn is equal to 1 by n is a convergent sequence which converges to 0. That is xn, we denote it by xn converges to x, or instead of x I will write here 0, or that is one by n converges to 0. Is that okay?
Yes.
Yes, ma'am.
Which converges to 0. What is mean by mod of xn minus x? In another words, what can I say? In another words, what is mean by mod of xn minus x less than epsilon? X belongs to which interval? Oh, sorry, xn belongs to which interval? Xn belongs to which interval? X minus epsilon, x plus epsilon for all n greater than equal to n0.
Yes, ma'am.
Is that okay? You can see this by drawing a graph of 1 by n. What is 1 by n? Can you draw the graph of 1 by n? Try. Can you draw the graph of 1 by n? N versus 1 by n you can take. One, two, three, 4, 5 and so on. And here 1, 2, 3. What is this? This is 1 by n and this is n. Right? This is n and this is xn. This is my n. If I vary n, I will. So if n is equal to 1, what is xn? It is 1.
Yes, ma'am.
If it is 2, what is my xn? It is 1 by 2. 1 by 2.
1 by
If it is 3, 1 by 9.
1 by
1 by 3, 1 by 3, the point 3, like that. So going, so it will go like this, not exactly to 0, but it will go near to 0. Are you getting?
Yes,
Yes, ma'am.
So you can see here all your xn's are in this interval only. You take any epsilon greater than 0. Suppose my epsilon is this. So 0 minus epsilon and epsilon. This is okay. I can't. Can you, if I rotate like this, I can do or not, don't know. This, you say this is minus epsilon and this is epsilon. This is my 0, na? 0. So for every epsilon greater than 0, x minus epsilon and x plus epsilon. Okay. What is my x? X here 0. So each xn belongs to minus epsilon and plus for all n greater equal to some n naught. Some n naught you take. N naught is equal to 5 you take. So after this all xn lies between this, right? Are you getting this?
Yes, ma'am.
For every epsilon you should get one n naught, means you should find one n naught. Suppose if I take my epsilon is equal to this, like this interval. Say if I increase epsilon value, then you can take n naught is equal to 1 itself. So xn belongs to minus epsilon plus epsilon for all n greater than equal to 1, right? Here n naught I am taking here 5. In first case, when my epsilon is small, epsilon is half, suppose. Say here half, minus half. Here say it is minus 2 epsilon. If I change value of epsilon, my value of n naught will change. Are you getting this?
Yes, ma'am.
एप्सिलॉन जर मी मोठा घेतला तर मला एन नॉट कुठे इथे जवळपासच कुठेतरी मिळेल. इफ आय टेक एप्सिलॉन इज व्हेरी व्हेरी स्मॉल मीन्स नियर टू 0 it will be, then my n naught will be something 100,000 or 2,000 like that. So we have to prove also that what is that n naught. Okay, just by graph I am saying this. Okay, we have to prove this 1 by n actually tends to 0 by finding that natural number n naught. Is that okay? Now next we will show that 1 by n tends to 0. Take example. Show that sequence 1 by n tends to 0. When I will say this is tending to 0, if for given epsilon greater than, by our definition, by this definition, if for given epsilon greater than 0, I want to find n0 natural number, okay, which satisfies this condition. Mod of xn minus 0 is less than epsilon for all n greater than equal to n naught. Okay, so I will start with epsilon greater than 0. So let epsilon greater than 0, arbitrary epsilon we are taking, and for this arbitrary epsilon, if we can find a natural number which satisfy the condition mod of xn minus 0 is less than epsilon for all n greater than equal to n naught, then I will say it that sequence converges to 0. Is that okay?
Yes, madam.
Okay, so let epsilon greater than 0. We want to find, what is my claim? There exists n naught belongs to n such that mod of xn minus, what is my xn? 1 by n. Xn is my 1 by n. So instead of xn, I will write just 1 by n is less than epsilon for all n greater than equal to n naught. Right? If we can find such n naught, I can say 1 by n tends to 0. Right? So let epsilon greater than 0. So for this epsilon greater than 0, by Archimedean property, what can I say? What can I say for this epsilon greater than 0? Epsilon is now real number greater than 0. So for this epsilon greater than 0, by Archimedean property, there exists a natural number n0 belongs to n such that what? N naught times epsilon is greater than y, but y I can choose as 1.
Yes.
Yes. Nx is greater than y, na? So n naught x is my epsilon, which is strictly greater than 0, and greater than y means y I am taking as 1. So that is 1 by n naught is strictly less than epsilon. right? By Archimedean property, there exists a natural number n naught such that 1 by n naught is strictly less than epsilon. Now let n greater than equal to n naught. Then what can I say about 1 by n naught and 1 by n? What can I say about whether it is less than equal to or greater than equal to? Let n is greater than equal to n naught.
So 1 by n naught is greater than
Greater than?
1.
Okay, instead of this, I will write. I am taking now n greater than equal to n naught. So what can I say about 1 by n and 1 by n naught?
One by n less than 1 by n.
1 by n less than का?
Less than.
1 by n is less than or equal to 1 by n naught. But 1 by n naught is less than epsilon. Right?
Yes.
So that is,
Yes.
so 1 by n is less than equal to 1 by n naught, and which is less than epsilon. So for this arbitrary epsilon greater than 0, by Archimedean property, we are having a natural number. We found a natural number which satisfies this one, 1 by n minus 0 mod of, that is, I can write this as 1 by n minus 0 is strictly less than epsilon. Can I write like this? For all n greater than equal to n naught. Or we can say 1 by n, first we will write like less than epsilon. So for all n greater than equal to n naught, we are getting 1 by n is strictly less than epsilon. So I can write this as mod of 1 by n minus 0 if we write or not, it doesn't matter, is less than epsilon for all n greater than equal to n naught. Is that okay?
Yes, ma'am.
Therefore, we can say that this implies 1 by n tends to 0. Is that okay, this example? We have started with arbitrary epsilon. Take another example now. Similar example. 1 upon n, show that one upon n plus 1 tends to 0. So how can I start now? For every epsilon greater than 0, I want to find a natural number such that mod of 1 by n minus mod of 1 upon n plus 1 minus 0. Right? What is my claim? For every epsilon greater than 0, there exists n naught belongs to n such that mod of 1 upon n plus 1 minus 0 should be less than epsilon for all n greater than equal to n naught. That is my claim. So let epsilon greater than 0. So for, if we start with arbitrary epsilon, for this epsilon I want to find a natural number which satisfies this property. Okay. So again Archimedean property I can use. By Archimedean property, what I have? By Archimedean property, there exists n0 natural number such that what? 1 upon n0 is less than what? 1 I can say, less than epsilon I can write. n0 times epsilon is strictly greater than 1. Right? Same thing what we did in previous example. Is that okay? 1 upon n0 is strictly less than epsilon. Now, so now I want to prove this one for n greater than equal to n0. So what is the relation between n plus 1 and n? Or for n greater than equal to n0, for n greater than equal to n0, what about 1 upon n less than equal to 1 upon n0, which is less than epsilon, right? And for n greater than equal to n0, or I can write n plus 1 will be strictly greater than n. For n greater than equal to n0, whatever natural number, n plus 1 is strictly greater than, or this also I can write. N greater than equal to n0, then n plus 1 will be also greater equal to n0, strictly greater, not equal to, it will be actually strictly greater than n0. So what can I say about 1 upon n plus 1? 1 upon n plus 1 will be less than equal to 1 upon n0. Actually, it will be strictly less than, right?
Yes, ma'am.
And it is less than epsilon. So this implies mod of 1 upon n plus 1 minus 0 is less than epsilon for all n greater than equal to n0. So this implies 1 upon n plus 1 is convergent to 0. Is that okay?
Yes, ma'am.
Now you take exercise.
Yes, ma'am.
Yes, now you take exercise. Show that 1 plus 1 by n converges to 1. Sequence 1 plus 1 by n converges to n. Okay. So this is your homework also. Second, show that 1 upon sequence 1 upon n square converges to 0. Is that okay?
Yes, ma'am.